The last problem was meant to illustrate what the different different values were. What was the total money flow, what was the present value, the future value. But the way it was set up was too simple. There's no way we're going to tell you exactly how much interest we'll get. There's no way we're going to tell you how much money in total. Those are things you'll have to compute. So in general, we'll give you the rate at which money is coming in. So the setup will be so we'll be given a function f of t, and that's the rate at which money is coming in dollars per year. Alright, so that's what we'll give in problems. We'll give this and the interest rate, and you'll have to use this to compute the total money flow, to compute the interest, the future value, the present value. Alright, so let me just do one easy, simple, well not easy, one simple example of f of t. Let's say that the rate at which the money is coming in is constant. Always the same rate. The flow of money is steady. So assume that Benjamin Coe is getting a constant rate of money. Is getting, actually, let me phrase it differently, this is a bit awkward, is getting $10,000 over 5 years at a constant rate. And I want you to help me figure out what FT is. Alright, so we're told the rate is constant. That means FT is constant. So FT is constant. So it's some amount of dollars per year. Well, what should that K be? Well, I'm getting $10,000 over 5 years. And so if it actually is coming out at the same rate in every single second, that means I'm getting $2,000 per year. And so let me draw a picture. So we start at time 0. We have f of t here, which is $2,000. And we're looking at 0 to 5. So this is at a height of $2,000. And something I want you to notice is, what is this area? Well, the width is 5 for 5 years. The height is 2,000 for $2,000 per year. So the area would be the product. So it's $2,000 per year times 5 years. And so we get $10,000. And so the area under this curve, in this case and in all cases, will be the total money flow. That's your capital. All right, so let's write the formula that we just learned, and I'll show you the other formulas as well. Let me take this so that they're in the same order. This is so I'm assuming that I'm investing money at a rate of f of t. And assume that we're investing that money at a rate of R per year. And assume that this goes on for t years. Then from our picture here, you could see that the total money flow is going to be the integral from 0 to t of f of t dt. Alright, so that's the area under the curve, and that's going to tell you how much money it was coming into the company's pocket, how much money was invested. Again, capital only, no interest. Alright, second. Now if I'm looking at the future value, I want to take an integral again, and I want to integrate f of t again. So that's the money I've received. But at f of t is money at time t. I still get to earn interest on it from time t, small t, to time big T. So that means that I'll get interest for t minus little t years. So that big T minus little t, that's the number of years in the investment. And the third, the present value. Well, we already isolated it in the equation. What we got is always true, so it's e to the minus rt future value. But we can actually bring this into the integral, and what we'll get is that the present value is f of t. The RT here will cancel with the RT there, so I'll be left with you can almost think of it as investing the money for minus t years. So if I'm at time t, I care about the value at t0, so I go back in time minus t years and I see how much is in the account. Okay. So if you have to compute PV only, then you can use this integral. If you've already computed FV, don't compute a second integral, use that one. And the same goes the other way. If you've already computed PV, don't recompute an integral for FV, just use this relationship here. So let me rewrite it in the other way. Big T, sorry. Alright, so there are the three computations that we'll probably ask you to make. TNF, future value, present value.